Okay, so we're looking at the hypotenuse leg congruence theorem. It'll be the fifth of our congruence postulates theorems, and this is the one that can be used with just two pieces congruent. It may look like a side-side angle case. It only works if you have a right triangle. So I'm going to copy down the given here. We're given these two triangles here with AC perpendicular to BD. So AC is perpendicular to BD. Let's go ahead and put a little right angle marking there and there. And then AB is congruent to AD. Those represent the hypotenuses of this triangle. We're going to go ahead and in step 2 write down the fact that triangles ABC and ABC are right triangles. So write that down next. So triangle ABC and triangle ADC, I don't have much room here, are right triangles. And that's by definition of what it means to be perpendicular. This perpendicular creates two right angles and therefore right triangles. So definition, we'll just put definition of perpendicular. This is one where you could argue, you could make this multiple steps. If you had a fill-in-the-blank proof on this, on a multiple choice, there might be multiple steps to get to that fact that they're right triangles. They might say, by definition of perpendicular, those are right angles, and then because they're right angles, they are right triangles. So they might break it into two steps. Just be aware of that. For my purposes, you don't need to do that. Just demonstrate that you understand these are right triangles. And number 3 here. So now we've established the right triangles. We have hypotenuses that are congruent. Remember, the hypotenuse is what the little right triangle marker points at. You remember that? The little right triangle, if you follow the corner of it out, those are the hypotenuses. It's the longest side of the right triangle. So it's a right triangle. Hypotenuses are congruent. We need one more piece congruent, the side or leg. And it is a share side case, right? So we've got AC congruent to AC. So AC is congruent to AC, and that's by reflexive property. Reflexive property. And then in step number 4, we'll be using this new theorem, which we abbreviate or have an acronym of it. It's HL. So triangle ABC is congruent to triangle ADC, and that is by the HL theorem. HL theorem. By the way, you can prove this theorem true by using our isosceles theorem that says the opposite sides of an isosceles, or the base angles, are congruent. So that's how you get angles B and D congruent in the proof of this theorem. And if angles B and D were congruent, these triangles would actually be congruent by angle side. That would be another step in this too. So you could use angle side to prove that they're congruent. All right, it says your classmate says there's not enough information to determine if the two triangles below are congruent. There's not enough information to determine if the two triangles below are congruent. So your classmate might be looking at that, thinking, I see an angle that's congruent in each one, I see a side that's congruent, and then I see that they share a side, but their argument would be that this falls into the category of the side-side angle theorem. But the question you have to ask is, if this is a right triangle, is it the hypotenuse that is one of the pieces that's congruent in each one of these? Is that the case in these? Is it the hypotenuse that is marked as congruent? There's a hypotenuse marked congruent to a hypotenuse over here. Right? So that is enough. As long as it's a hypotenuse, it's marked as congruent. If it were just a couple of the legs that were marked as congruent, then it wouldn't work. But since the hypotenuse is marked as congruent, they are congruent. So there is enough information by the HL theorem. Okay, so as soon as you have a right angle marking in there, kind of be aware of that. Don't assume that right angle marking means you're going to use the HL theorem. Don't assume that. Okay. But if you have a right triangle and you have the hypotenuses are congruent as well as one of the other legs in the triangle, then that is enough information. So it's the only one in which you can do it with two pieces congruent. So any questions on that? All right, so you'll be asked, and they're going to, also in the homework too, and on the proof packet, you're going to be asked to use everything now that you've learned. So all 5 of these, you now have 5 to work with. So are the triangles congruent by HL here? Are the triangles congruent by HL? This is, we're trying to trick you here. They look like right triangles, but what makes them right triangles in the drawings and geometry? Yeah, they gotta have that little marking. So since they don't have the little marking, they are not marked. I'll maybe underline the word marked as right triangles. They sure look like it, but we cannot use the HL theorem to prove they are congruent. So we just say not enough information. Yeah, not enough information. It's not that they aren't congruent, maybe they could be, but we don't have enough information to prove that they are congruent. So we're looking for those right triangles. If they shared a side, I might be able to prove they are congruent by one of these others, but they don't. It's not enough information. And it's really based on the fact that they are not marked as right. All right. What about down here? Yes, looking like it. Where's the hypotenuse? Right.
It's
in the middle one.
Reflexive.
It's the reflexive one, yeah. So here it is. It's pointing right at it. And then the other two are just legs. Doesn't matter which leg goes in there. So this one has, yes, enough information. And you might want to add in it, you got to use reflexive. Reflexive gets hypotenuses congruent. So reflexive does it. That's it. So the big idea here is make sure that somewhere within the given, it's either stated that they're right triangles or you can prove that they're right triangles before you use the HL theorem. Okay.